They called it the most powerful steam locomotive ever built. 4,416 tons of steel and determination, hauling freight over the Wasatch Range at speeds that made engineers nervous and accountants hopeful. The Union Pacific Big Boy. 25 of them rolled out of American Locomotive Company between 1941 and 1944. They were never supposed to be gentle. They were supposed to move tonnage. But deadly? That's a different question. The safety record tells a story the promotional materials didn't. Between 1941 and 1959, about when the last Big Boy made its final run, Union Pacific operated these machines across some of the most unforgiving terrain in North America. Wyoming winters, Nevada heat, mountain grades that punished every mechanical system, and the crews, firemen, engineers, brakemen, who rode them through all of it kept logs, filed reports, documented every incident, every close call, every injury. The numbers exist. They're just buried in archives most people never see. Let's start with the basics. A Big Boy weighed over 1 million pounds. The boiler alone carried 300 pounds per square inch of steam pressure. That's not a margin for error situation. That's a potential bomb on rails if something goes wrong. And things went wrong. Not often. But when they did, the consequences were measured in hospital beds and funeral expenses. The first recorded serious incident happened in November 1942. Big Boy 4002, eastbound from Ogden with a freight consist stretching 1.5 miles behind it. The fireman, a man named Walter Griggs, was feeding the firebox when a steam fitting failed. Not a catastrophic boiler explosion. Those are rare, despite the mythology, but a high-pressure steam line rupture inside the cab. The report described second-degree burns across Griggs's arms and face. He survived, spent 6 weeks recovering, never came back to steam locomotives, requested a transfer to diesel switch engines the moment he was cleared to work again. That incident went into Union Pacific's internal files. Not a fatality. Yes, not a derailment, just an injury. The kind of thing that doesn't make newspapers but gets recorded in crew memos and maintenance logs. The Big Boy fleet accumulated injuries the way any industrial equipment does. Pinched fingers from coupling mechanisms, burns from hot metal surfaces, back strains from shoveling 16 tons of coal per shift. These weren't design flaws unique to the Big Boy. They were the realities of steam locomotive operation in the 1940s. But the scale mattered. Everything about the Big Boy was bigger. The firebox was larger, which meant more coal, which meant more physical labor per mile. The boiler was longer, which meant more surface area that could burn you if you touched the wrong spot while making adjustments. The tender carried more water and fuel, which meant longer shifts without stops. Crews noticed. Union representatives filed grievances about working conditions. Not because the Big Boy was uniquely dangerous compared to other steam locomotives, it wasn't, but because the sheer scale of the operation amplified every existing risk. A small steam leak on a smaller locomotive might be a nuisance. The same leak on a Big Boy, operating at higher pressures with larger volumes, became a hazard that required immediate shutdown and repair. The deadliest incident involving a Big Boy didn't happen because of the locomotive itself. It happened because of what the locomotive was pulling. January 1945. Big Boy 4014, westbound through Echo Canyon in Utah. The train was heavy, over 5,000 tons, and the grade was steep, standard operating procedure. So the crew was experienced. But a coupling between the 63rd and 64th car failed under stress. Not an unusual event. Couplings failed regularly on heavy freight trains. The protocol was established. Emergency braking, secure the separated section, radio for assistance. But the separated section was on a grade, and winter conditions meant ice on the rails. The rear portion of the train began rolling backward, gaining speed. The brakeman, trying to manually set brakes on the runaway section, slipped on ice-covered metal, fell between cars. The official report listed the cause of death as accidental fall during emergency braking procedures. Not a big boy problem. Not even a coupling problem, really. Those fail on every railroad. A convergence of terrain, weather, and circumstance. Union Pacific didn't retire the big boy because of safety concerns. They retired them because diesel-electric locomotives were cheaper to operate and maintain. The last big boy revenue run happened in 1959. Yet by then the fleet had logged millions of miles. And the injury rate? Lower than smaller steam locomotives operating in urban switching yards. Lower than the accident rate for highway trucks hauling similar tonnage. Lower than what actuaries predicted when Union Pacific first ordered them. That's the paradox. The machine that looked most dangerous, massive, powerful, operating in harsh conditions, turned out to be safer than the alternatives it replaced, partly because of engineering. The big boy was overbuilt. Redundant safety systems, thicker boiler walls than strictly necessary, pressure relief valves that could handle surges other locomotives couldn't. But mostly because of crew training. Union Pacific knew they couldn't afford mistakes with equipment this expensive, so they selected experienced crews, required additional certification, ran simulator training. Primitive by modern standards, but ahead of its time for railroad operations. The firemen who worked big boys described the cab as cramped but methodical. Every control had a purpose. Every gauge told you something vital. You didn't have to guess. The steam pressure gauge was right there. The water level sight glass was positioned where you couldn't ignore it. The throttle response was immediate. These weren't comfort features. They were safety features disguised as operational efficiency. Compare that to earlier steam designs. Locomotives from the 1920s and 1930s often had critical gauges scattered across the cab, requiring the engineer to look away from the track ahead. Throttle linkages that could stick or slip. And boiler designs that built up pressure unevenly, creating stress points that failed without warning. The big boy inherited 2 decades of hard lessons. Every fatal boiler explosion, every crew injury, every mechanical failure that made headlines, those all fed into the design specifications American Locomotive Company followed. The result was a machine that killed fewer people than it should have, statistically speaking. Railroad work in the 1940s was dangerous. Period. As switchyard accidents killed more workers annually than the entire big boy fleet did over its 18-year operational life. Derailments on branch lines, smaller locomotives, lighter consists, slower speeds, had higher fatality rates. The big boy operated in the most visible, most scrutinized environment. Mainline freight, high tonnage, long distances. Every incident got reported, investigated, documented. The mythology around the big boy focuses on power. 2,300 horsepower at the drawbar, 6,000 horsepower equivalent in total output, pulling 5,000 tons up a 2% grade. All true. But the engineering achievement wasn't the power. It was making that power controllable, making it reliable, making it safe enough that Union Pacific trusted crews to operate it in conditions where failure meant death and property damage measured in millions of 1940s dollars. The last big boy in regular service, number 4024, made its final run in July 1959. The crew that day included an engineer who'd been with Union Pacific since 1923, 36 years on steam locomotives. He described the big boy as the safest machine he'd ever operated, not despite its size and power, but because of it. The engineering margins were wide enough to forgive mistakes. The controls were precise enough to prevent most mistakes in the first place. And when something did go wrong, the redundant systems gave you time to respond before it became catastrophic. That's not the story people expect. They want drama. Now they want tales of near-death experiences and heroic engineers wrestling with uncontrollable machines. The reality is more mundane and more impressive. A well-designed piece of equipment operated by well-trained crews, working within established procedures, rarely kills anyone, even when it's hauling 5,000 tons over mountain passes in Wyoming blizzards. The big boy wasn't deadly. It was, by the standards of its era and the work it performed, remarkably safe. Which doesn't make for exciting headlines. But it makes for good engineering, and in an industry where mistakes cost lives and fortunes, Good engineering is the only thing that matters.